Hi everyone, this is Yukabuka and welcome to my home on YouTube. In this video, we will look at a series of patches that have been applied to the Linux kernel. So in addition to the video series on reading kernel code, I imagined it would be a good idea to have a series where I read through the sources of various kernel commits that have been applied as well. In this specific video, we look at the patches that were applied to the Linux kernel in order to move the threadinfo data structure into the task struct. And we look at these patches for the x86 architecture. As we can see here, we are specifically looking at 5 patches that hopefully encompasses a major part of this move. So without further ado, let's look into the code. Before I start reading the patches, a bit of background. There are two data structures within the Linux kernel that are very important. One of them is the task struct data structure, and the other is the threadinfo data structure. The task struct data structure is the schedulable entity of any given executing task in the Linux operating system. So for every thread and for every thread in the Linux kernel, there is a corresponding task struct, and this is what the scheduler uses to schedule the various tasks. Each thread also has its own threadinfo data structure, and that is used to contain information that is local to that specific thread. We will look at initially the threadinfo data structure was located on the kernel stack. So every thread would have its own thread kernel stack, and the threadinfo data structure would reside on that kernel stack. These patches discuss the move of the threadinfo data structure from the kernel stack into the task struct data structure. Now the task struct data structure is allocated using kmalloc, and it is allocated from a slab which is used for allocating just task struct objects. It's not used from one of the more general purpose kmalloc slabs. Okay, so without much further ado, let's start looking at these patches. First of all, we have a patch here that says move threadinfo status field into the thread struct. Okay, now the thread struct is yet another data structure which should be inside. I think there is an instance of thread struct within the task struct, but I could be wrong. Let's take a quick look at what this patch does. So first of all, inside arc-x86 entry common.c, we see that the TI field is replaced with current arrow thread, right? So instead of accessing the TI, which I guess would be the threadinfo in most cases, we have current arrow thread dot status. Right. Okay. Yes. Okay. Got it. So this TI used to refer to the threadinfo data structure, and current refers to current is a pointer to an instance of task struct. So once the status field would be moved from thread info to thread struct, which is a data structure inside task struct, these lines become equivalent. Now, status is a field that contains various bits indicating, well, the status of the process, such as whether or not it's running in 32-bit compatibility mode within a 64-bit on a 64-bit CPU or so on. So I believe status also has certain bits to indicate whether or not the process is being p-traced or not, but that is a gist of what status represents. Yeah. And now you can see that there is yet another location where ti arrow status is used, and it's being replaced by current arrow thread dot status. Yeah. And over here inside processor.h, we can see that there is a struct, thread struct, into which the status has been introduced. The status field has been added over here. Looks good. There is also a new flag that has been introduced, ts_compat, which is a 32-bit syscall active. This is different from the flags in that nobody else ever touches our thread synchronous status, so we don't have to worry about atomic accesses. So this is a thread synchronous status, and in the same file as where they introduced status, they have introduced a macro called ts_compat. Okay. I am not quite sure of why they have introduced this new macro over here, when there probably was, when this macro was probably defined at an earlier point in time, seeing as to how you have a ts_compat here. So I wonder if it's just moved files from somewhere else into the specific file. I'm not sure. Let's keep going. In this specific case, we have an instance of task thread info arrow status. Right. So task thread info is a macro that takes in a task struct instance and returns the thread info. So instead of using the thread info arrow status, we have changed it to task arrow thread dot status. Fair enough. There is another similar change here, another similar change over here. And what is this specific change? They have taken off or removed an entire chunk inside syscall get arc and replaced it with this. So what was it earlier on? Earlier on, if there was config IA32 emulation, then, and if it was running in compatibility mode, then it would return audit arc i386, else it would return x64. Okay, and now there's a new macro or a function which presumably does the same thing, but then returns whether or not it's on a 32-bit or 64-bit system. I'm not sure if this was introduced within this commit or in some other commit. So in this function, yes, we can see that ts_compat has just been removed. So it's the same set that was removed from this file and added to another file. And over here we can see that in IA32 systcall has been defined. And what is the condition here? If def x86-32, then yes, it is always running within a 32-bit system call. And if that is not the case, then it checks if the config IA32 emulation config is enabled that is the kernel compiled with support for compatibility mode, and if the current task is running in compatibility mode. So that is what this macro checks. It is interesting to note that there is a macro called is_enabled, which allows us to check if a certain configuration variable has been is being used within macros such as this. So that's kind of nice. Right. Okay. I'm slightly curious about what is_enabled resolves to. So let's take a quick look. Okay. So is enabled config foo. So it does an OR of, is it a built-in or is it a module? Okay, let's take a look at, is it a built-in? Oh, it's in the same file. So built-in checks if it's defined this option, and module checks if it's defined as option #_module. Okay, and what does __ is defined resolve to? Okay, we see that there is a chain here. Okay, it goes to placeholder ##val take second arg. Okay, getting something that works in C and CPP for an arg that may or may not be defined is tricky. Here, if we have #define config_booger1, we match the placeholder define, insert the 0 for arg1, and generate a triplet. Then the last step cherry picks the second arg, a 1. When config booger is not defined, we generate a something 1-0 pair, and when the last step cherry picks a second argument, we get a 0. Interesting. Right. So if you have a config under something 1, then it's, well, replaced by the 1, right? So the __ is defined of x val, what you have is __arg_ placeholder, which by the way is a 0, right? And then you do a ##val, right? So if it's a 0, then what happens then? I can see that __arg placeholder _0 is not defined here. So if it's take second arg of arg1 or junk 1-0, in which case it's just a 0, I guess. When it is not defined, we generate a something 1,0 pair, and when that last step cherry picks the second argument, we get a 0. Right, because __arg_ placeholder _val wouldn't mean anything if it was not defined, and if it was not defined, then 0 is what gets picked up, I guess. Okay, interesting. Okay, so what else do we have? We see that from within asm-offsets.c, status has been removed. Yes, so asm-offsets.c is an interesting C file where you have multiple lines with entries along the lines of offset something, a data structure, and a field. Now the names such as ti_flags, ti_status, etc. can be used within the assembly code in files such as entry.s and head.s. That's the reason you add something to a file like asm-offsets.c. Okay. And then you have a file called init.c inside FPU where there is apparently a use for status, and that line is just removed. Again, we have some more usages of current thread info replaced by current arrow thread. We have a usage of task thread info of child arrow status replaced with child arrow thread.status. Okay, that makes sense. And it's the same thing over here as well. Okay, so we've gone through the first commit, which is fairly straightforward, that moves a field from inside the thread info to the thread struct. Let's look at the next one. The next one gets rid of the pt regs to thread info macro. The commit message here is amusing. And what does this do? So what pt regs to thread info does is it takes pt regs, it tries to calculate the lowest address of the kernel stack, and then return the address of thread info. Okay, so I wonder if regs +1 is somehow the stack pointer, and if top of kernel stack padding is a negative value. Not too sure though. You can quickly check Elixir. I'm not sure if this will be correct. It seems to be. In all of these cases, it seems to be a positive value. In that case, the register +1 won't be the stack pointer, right? It should be something else. Yeah, there should be some other reasoning behind this, because but there is something else though. You have the top of the stack minus the thread size. Interesting. So this would or should have pointed to the highest address within the kernel stack. That should be the top of the stack. And if that's the case, then top of the stack minus the thread size would point to the lowest address in the kernel stack. That's kind of the only way this would make sense, I guess. So perhaps at the highest address of the kernel stack you have the pt_regs, which is interesting. I did not know that. Okay, so let's take a look, and what's happening here is that all occurrences of pt regs to thread info are being replaced with current thread info. You have that arrow flags, it's replaced with current thread info arrow flags, and you can see that that change is happening everywhere. Okay, interesting. Currently, how is current thread info defined for x86? Let's see. This should be the one. Okay, so because thread info is going to be moved in as the first item of the task struct, they are simply dereferencing the address of the task struct in order to obtain the thread info. Fair enough. So the rest of the patch is pretty much the same. It just replaces one function with another macro. Let's take a look at the next patch. The next patch is stop conflating task struct stack with thread info. Yes, this is a very interesting patch because it is clear from this patch that prior to this series of patches, the thread info or functions that worked with the kernel stack or were meant to operate on the allocation or the freeing of the kernel stack instead expected as argument a pointer to the thread info. And this would technically work because the lowest address of the stack and the address of the thread info were the same. However, it is just much cleaner to have the kernel functions specify that they allocate and deallocate the stacks rather than have these functions expect thread info as the argument. So let's take a quick look at these functions. What it does is, in cases where you have thread info of child arrow stack arrow CPU, you now just have a task CPU of child. Right. So this is effectively an effect of moving the CPU field from, let's see, in this case it's taking the stack and it's taking a CPU. Right, it's taking the thread info. So child is the task struct. Child arrow stack refers to the stack of that particular task, the kernel stack, and you can see that it's being typecasted to type thread info, and CPU is being dereferenced from that. So it's being replaced by using another macro which is much cleaner, that uses task underscore CPU, that uses the task struct to retrieve the CPU value. I also believe that the CPU field was moved from the thread info to the task struct in a separate patch, but yeah, that's different in any case. Okay, so the next patch is called allow putting thread info into task struct. Okay, so what the commit message says is that if an architecture opts in by setting config thread info in task struct, then the thread info is defined as a single U32 flags and is the first entry of a task struct. Okay. Thread info, if an architecture opts in, then the thread info is a single U32 flags. Well, if it's moved in, I'm not sure why. It's probably to make the compiler happy. I'm not sure. The next line says thread info : task is removed. Yes, because now thread info is inside the task struct, so there's no point in having this. And thread info : CPU gets its own slot in the task struct. Yes, so this is the patch that moves the CPU field from within the thread info to the task struct. Okay, let's take a look at the code and how it's changed. First, we have include linux init task.h, and inside this, what they do is the .thread info is made to, so if it's within the, or if the config thread info in task is defined, then init task ti is a macro that does this. Right, we'll probably see this being used later on. And otherwise, it's just an empty macro. Now you can see why this is being done, because there is a macro to initialize the task struct data structure for the init task, and that is called, well, init underscore task. And within it, there is a macro called init task ti. So as we've just seen, this macro will evaluate to an empty expression if config thread info in task is not set. Okay, now yes, so this is the part where the structure is moved into the task struct. We can see that the CPU is also moved into the task struct if necessary. There is a structure called thread union. Now the thread union normally contained the thread info data structure and the stack, but now we can see that it's been removed from the kernel stack if this particular option is set, and if this is not set, then it's again at the lowest address of the kernel stack. That's why we have a union here. So it's interesting how they've implemented this. We have a few more options here, and that is if the config thread info in task is defined, we have a few functions defined, and those are task thread info, that is given the address of a task, retrieve the address of the thread info, and that essentially does task arrow thread infos ampersand. And this might have been written with the intent of being able to place thread info at a different offset within the task struct, but as it is, I don't see why there should really be a function for this. Perhaps it does make things clearer, and it does make it easier to replace earlier code that might have a function or a macro named task thread info defined. So yeah, in that case it does make sense. Yes, exactly. So if we look down here, we can see that if this macro is not defined, task thread info is essentially task arrow stacked and dereferenced with or task arrow stack typecasted to struct thread info star. So that makes sense. The next one is task stack page, in which case it just returns task arrow stack. There is a new macro setup thread stack, which is something that evaluates to nothing. Okay, interesting. I guess it does something if I guess it might be doing something if if config thread info in task is not set. I'm not sure. There is also something called end of stack that returns task arrow stack. I find this terminology of end of stack to be mildly confusing. It's hard to understand what people mean when they say the end of the stack or the top of the stack or the bottom of the stack, because different people look at this in different ways. It's easier to say that this is an address towards the lower end of the kernel stack, or towards the higher end of the kernel stack, or so on. I think that's better. And then there's a task CPU. Yes, we did see this in an earlier patch over here. I think it was this one. We saw various calls being replaced by task CPU. And what task CPU does is, if it is config thread info in task, we return p-arrow CPU because the CPU field has been moved into the task struct. Else, we use task thread info to retrieve the CPU value from the thread info corresponding to the task struct passed into the function. Okay. So there is another function, include linux threadinfo.h, which essentially defines threadinfo to be a field with just one 32-bit value. Okay, and if so, I'm not sure why this has been added in. I'm not sure if this has been cleaned up later on either, but perhaps it's for the compiler. It's to satisfy the compiler in some way. I'm not too sure. Yes, and we see that current thread info is defined to simply typecast current to type struct thread info star. So that makes sense. Inside kconfig, the option thread info in task has been introduced, and we can see that there is a it's defined to be a bool value, I guess, with some help text. Okay, and then we have the init task.c, where the thread union for the init underscore task is defined, and the thread union for the init underscore task is not surprisingly called init underscore thread underscore union, and it's initialized using the init underscore thread info of init task macro. Right. Yes, and the thread union contains the stack and the thread info, so it needs to do the initialization based on whether or not this option is set, I guess. So what this does is, if not defined, then you init the thread info. So init thread info does not do anything related to the stack. It only initializes the thread info, and if this option, and it needs to do that only if this option is not set. So that's what it's doing. And then we have some changes inside shed.h, where there is an attempt at fetching the or storing the CPU value. So depending on whether or not the config thread info in task value is set, the CPU variable is set to different locations. Now we have the last patch, which is the x86 specific patch for moving thread info into task struct. All of the changes we saw in this previous patch were not specific to x86. They were parts of the common kernel implementation. Now in this last patch, we will look at the x86 specific bits of making this transition. We can see that within the kconfig file, thread info in task has been selected by default, and there are a few changes within the entry sorry the entry underscore 64.s file, and inside this file we have the entry path for system calls, which are in 64-bit mode, I believe. And what is going on here though? We used to have a test instruction, but instead of that, there is a per CPU variable which is being moved into R11, and the flags are being checked over here. Right, so I think this is a result of the move of the status variable, but I'm not quite sure. This could, I believe the flags field was also moved in some other patch. Let's do a quick check for what this means. Elixir. Okay, so I'm unable to find this. Yes, so in any case, this seems to be an attempt at fetching the current task, and this seems to be checking if these flags are set within the flags field over here. Right. And it seems to be the same case over here as well. What was it early on though? Earlier, before the changes, it used to be retrieving the flags field from within thread info, I guess. That seems to be the case, I'm not sure. Okay, then we have the x86 version of thread info, where thread info is completely being removed. We can see that the init thread info macro has been removed. Both of these have just been removed. We have a current thread info function that retrieves the thread info, but that's been removed as well. And then we have the ASM thread info, which is removed. We saw this being used in the assembly code earlier on inside N364. So let's take a quick look at what this does. For example, to fetch the current thread info arrow flags value. Yes, so this means that flags used to be inside thread info. Into %EAX, you would do in syscall entry code where RSP is currently at exactly size of PT regs away from the top of the stack. I see. Okay. So that is what this macro means. That is, this would be the field that you're interested in retrieving, and this would allow you to find where the thread info is, right? So these two arguments would allow you to evaluate where the thread info is, and this would be the field that you're interested in from that data structure. Okay. And task TI flags has been added over here. It used to be TI arrow flags, and now it's inside, okay, task TI arrow flags. So the flags field is still inside the thread info. It has not been moved anywhere. It's just that the thread info itself has been moved inside the task struct. Okay, and then you have an interrupt handling code change, where, let's see, instead of using the thread info for any calculation, you just don't use it anymore. And you have the bottom of the stack calculated without using thread info either. Interesting. So these are more or less the series of patches that have been applied to the Linux kernel in an effort to move the thread info structure into the task struct. I hope you've enjoyed this short video. If you've liked it, hit like and subscribe.